All right, here's a probability question. There's six multiple choice questions. Each question has four possible answers, right? A, B, C, D. Only one is correct. So the first part of the problem is kind of easy. What's the probability that somebody's going to get them all right simply by guessing? So you list out all the questions. What's the probability that he's going to get the first one right? 1 out of 4, right? Because only one answer is correct out of 4. How about the second question? Same. How about the third question and fourth question? They're all the same, right? So each question has the same probability that somebody's going to get the right answer simply by guessing. So what do you do with these quarters? You multiply them because it's a logic problem. So what you're really doing is you're substituting the word "and," which means multiply in logic, right? So we got question 1 right, and 2 right, and 3 right. So you feel that "and" whenever you hear yourself say "and," it usually means multiply in logic. So the answer to this one is simply 1/4 raised to the 6th, which comes out to be one chance out of 4,096. Okay, that part wasn't that bad. So that's the probability that he can get all 6 correct. The second part gets harder. So now we want the probability that the student will get at least 5 correct. So that's at least 5 and the 6th part. So we're going to figure out what the probability is to get 5 and then add in that 1 over 4096 because that's the 6th one. But here's the formula for that. All right, the probability that our random variable, you don't need to know that, is going to equal 5 is, so this n is the total possible. So that's 6. So this part right here says 6 chooses 5. That's going to be that factorial thing. P is the probability of getting a successful outcome on a single trial. So that's 1 out of 4. K is the number of trials we're talking about, and that's 5 in this problem. And then this 1 minus P is the probability of the event not happening. And then N again is 6 because there's 6 questions, and K is what we're trying to get is 5. So let's plug and chug some real values in here. So we're going to calculate the probability that this person is going to get 5 out of 6. So we're going to substitute that in. 6 choose 5. P again is 1/4. That's the probability of a successful outcome on a single trial. 5 is the number of trials. And this is the probability of an outcome not happening. So 1 minus 1/4 raised to the difference between 6 and 5. And the rest is just algebra, right? 1 minus 1/4 is 3/4. 6 minus 5 is 1. We don't need to write 1 as a exponent. And so we just multiply this all out. So 6 choose 5 is 6 factorial over 5 factorial times 1 factorial, which just comes out to be 6. So 1 over 4 raised to the 5th power is this. And then 3/4 is just 3/4. You multiply them all out, you get this. So that's the probability that he's going to get 5 correct. But remember, we got to add that to the probability that he's going to get all 6 correct because that is also at least, right? 6 is at least as 5. So we need to add those two together for a final answer of 19 out of 4,096. So that's the probability that somebody simply by chance alone would get at least 5 correct on a 6-question test. So I hope that helps. MGZ out.